So let's go over a surge tank today. Surge tank, super quick. So, surge tank, super quick. Kind of looks like a receiver, but it's not. It's a surge tank. So what happens? Well, got this little device right here, an Additron. Okay, at least for this one is. This is a relic from the past. I don't think anyone uses this anymore. So you see this thing that plugs in the bottom? We'll follow that out, right? Come over here. There's a looking eye that looks into here, right? And what it does is it looks at that sight glass, and if that sight glass is flashing, it has a sight glass there. If this sight glass is flashing out of the receiver, what it does is it says, oh my gosh, not enough refrigerant's being pushed out of the receiver. So what it does is it comes over here, and this is the surge valve right here. So it activates the surge valve, pumps your hot gas out of there, pumps hot gas. We're going to follow that surge valve. And what it'll do is it'll come up to the top of this tank right over here, into the top of that tank. Now it fills the top of this tank with high pressure, hot gas, and that hot gas will pressurize. It's like an aerosol can, and it pushes out the refrigerant out the bottom and out to your cases. Now this surge tank also seems to have this like relief valve here, where if it gets too pressurized, it'll let this suck out, and in this case this is just going to go into the suction and go back to the system. So anyway, so that's the surge tank. We're going to go to the pen and paper. I'm going to kind of explain it a bit to you too.
Okay, so surge tank compared to a receiver and how they kind of differ. So if you haven't watched the receiver explain video, I'd recommend doing that. It goes into detail about a receiver. This will kind of compare it to a surge tank. They're similar principles, okay? So with a surge tank, it's a little different. Okay, so you have your hot gas going up to your split. It splits off, goes to your condensers. Okay, it condenses down into a liquid, hits your holdback valve, and that's all kind of explained and receivers explained. The basic gist of it, and then it comes out of there. Now here's where it really differs from a receiver. So for a surge tank, there's like a T intersection in front of the surge tank. And what ends up happening is, it's like it goes to the path of least resistance. So when it goes to this T intersection, most of the time it's actually just going to flow directly out to your cases. So it's going to flow to your liquid header, and then it'll just flow out to your cases. And what happens is, when all your cases are flowing across your TXV appropriately, and you have an appropriate full column of refrigerant out to all your cases, this refrigerant is going to go, I can't go this way. It's filled with liquid refrigerant. And then what happens is it goes into the surge tank and it fills up the surge tank. Now what happens though is the surge tank doesn't have like natural pressure built into the top for multiple reasons. One, a lot of the time surge tanks are inside, so it's at a decent temperature. So you're not going to get a lot of evaporating of this gas in here. So you're not going to have a lot of pressure at the top, just because it's just not very hot inside. Okay, and for a receiver, we have this receiver pressure regulator over there that kind of pumps the top half of the receiver with hot gas, so what pushes the liquid refrigerant out. In a surge tank, we have what's called a surge valve, like right over here. So it's the same principle. So if you follow your hot gas line, you're going to find a solenoid valve on this, which is your surge tank valve. So what happens is it's a little bit different, but you have and you'll see it in the machine room video, but you'll have a little piece of equipment, and it'll have a looking eye right there before the filter dryer, not after, because if it's after the filter dryer, it can get confused with having a plug filter dryer, because if you have a plug filter dryer, it can make it look like you have low refrigerant. So the looking eye is before the filter dryer, and what the looking eye does is it sees, do we have a full column of refrigerant here? And if it goes, oh yeah, we don't have it, then it assumes, it says, okay, well, more than likely, if this is a surge system, we have gas, that means that it's stuck in the surge tank. So that little unit will activate your surge valve, and it'll pump hot gas to the top of your surge tank. And then you'll have a differential valve, in this application, in the one that I showed you in the machine room, you'll have a differential valve that'll bleed off your excess refrigerant into your suction side. So this differential valve is probably set for 100 psi above your suction. Okay, so for example, if this suction group is 50 psi, right, this differential valve, so this side of the differential valve will be 50 psi, even though it's red. I might have miscolored that. And this other side of the differential valve will be 150 psi, because we need this whole thing to work properly. We need refrigerant to flow from high to low, and as I mentioned in the receiver explain video, we need 100 psi of pressure drop across your TXV in order for it to work properly. So this side of the TXV, right, so what happens is a surge valve pressurizes the top of this tank, because this looking eye goes, there's not a full column of refrigerant there. I think I need to push some out of the surge tank. I think some's being left in the surge tank. So it turns on this valve, pressurizes the top, that bleeds off into your suction side. In this case, I've also seen it connected to the condenser liquid side. I've seen it connected in all kinds of ways, but it bleeds off to your suction side, leaving this at 150 psi in the tank. The 150 psi pushes the liquid refrigerant out, goes into your liquid header, out to your cases, and now you got this 150 psi right there, and then across that on the other side you got 50, which gives us that 100 psi differential that we need in order for it to work. So that's how you use the surge tank. So why would you do this? I don't know. If I'm honest, nobody uses them anymore. They're kind of a relic from the past. They seem to have been phased out in most applications. I only find them on older systems. I think that their thinking was it would give them more control, because you have this seeing eye. It's kind of a computer type of system. It has an automated. It's like it's not just a valve that regulates itself. It's like a actual system. I think their idea was it would give you more control. You can open the surge valve as you need, rather than have this kind of running all the time. But the issue with it, I find, is that when it gets low on gas, it just kind of dumps hot gas into this all the time. But so, an example of it is, I used it in the last video for Receivers Explained, but you can see, again, just like an aerosol can. So you got your surge tank right there, just like an aerosol can. So, this is a pump. It pumps in, pumps in some pressure on the top, right? So now we have pressure on the top, and on the bottom we have, in this case, oil. And then you can just see, like, it, same exact concept with this. As it pressurizes the top, sprays it out, or pushes it out to your cases. Anyway, I hope you learned something. That's a surge tank. That's how they work. That's how it kind of compares to a receiver. A couple noticeable differences is, a receiver's fed in through the top. A surge tank is fed in through the bottom. Okay, receiver, it has to go through the receiver in order to go to your system. And then in a surge tank, like I said, it can just bypass your receiver and go to your system, bypass your surge tank and go right to your liquid header and go right out to your cases. So I think this was kind of designed maybe to be more efficient, maybe to just get your liquid refrigerant right to your cases. But in practice, it's kind of been obsolete. But if you run across it, hopefully this will help you understand it a little bit better. Hope to learn something. Thanks for watching. Please, if you know anything more, comment below. I love it when people comment. I want this to be a place for people to learn. Please like, subscribe. That's how you do it.